All right, so we are going to start from this point. Hydrogen bomb. Okay, hydrogen bomb. So hydrogen bomb was set up or discovered or made by USA in the year 1952 by this personality called Edward Teller. So it works on the basis of uncontrolled fusion, because the same that occurs in the stars and the sun. So that is the fusion principle on the basis of which hydrogen bomb works. The first test was conducted in Marshall Islands. A fusion of deuterium plus tritium to give helium results in making of hydrogen bomb. So actually it is said hydrogen bomb, but actually what we do is we actually bring about or try to bring about fusion of deuterium with tritium. So we fuse deuterium and tritium to give helium, and this process is basically releases large amounts of energy, making a hydrogen bomb. So nuclear fusion of deuterium with tritium, that is the technical process discovered by Edward Teller, made by USA in 1952. Hydrogen bomb works on the principle of nuclear fusion. Now, advantages of thorium, that's the raw material of nuclear raw material that India is abundant with. Andhra has 35% of India's thorium reserves, then Kerala and Odisha produce, both of them together produce 70%. Alright, but Andhra has like 35% of India's thorium reserves. And if we talk of the number one region of thorium reserves in India, it has to be Kerala at the top and perhaps Andhra at the second place and Odisha at the third place. I'll just check that ranking. So Kerala and Odisha together produce about 70% of India's thorium. Okay, not produce, but they have 70% of India's thorium reserves. Okay, now thorium is more abundant in our country. I mean, there are several advantages of thorium over uranium. It is that thorium in general is more abundant in nature than uranium, and per unit mass of mined mineral, thorium can generate more energy compared to uranium. If we look at this from per unit mass point of view, per unit mass energy generation, then thorium goes ahead of uranium. So thorium generates more energy per unit mass compared to uranium. Then thorium produces less harmful waste compared to uranium. So these are the advantages of using thorium over uranium as a nuclear fuel. Then Rawat Bhata Atomic Power Station is in Kota, Rajasthan, whereas Kaiga is in Karwar district, Karnataka. Karwar is a district in Karnataka where Kaiga Atomic Power Plant is situated. Okay, is it atomic or? So Rawat Bhata is an atomic power station in Kota, Rajasthan, and Kaiga, whereas Kaiga is in Karwar. Kaiga is in Karwar. All right, Karwar district. Now nobody is going to ask you like what is the capacity of that power plant. Just remember which power plant is where. Then Kundankulam, this is in Tamil Nadu. This is very famous atomic power plant of Tamil Nadu, and is as per 2008 agreement between India and Russia, there will be 6 units constructed based on the I think pressurized heavy water reactor technology. So this employs the use of pressurized heavy water. 2 units are already operational here of 1000 megawatt each, and there are total of 6 units to be constructed based on the agreement of 2008 between India and Russia. Okay, so remember that it is based on pressurized heavy water reactors. Okay, 2 units are already functional. Now silver is the best conductor of electricity, followed by copper, gold, aluminum, iron. In the metals, electrical conductivity is due to the movement of free electrons, while in liquid and gases, it is due to the movement of positive and negative ions within the gas or liquid. So, however, in gases, conductivity takes place only at a definite pressure. Remember that. In liquid, it is still easier to conduct electricity in liquid, but in gases, you have to put the gas at a certain pressure first, and only then expect it to conduct electricity. Amongst the metals, इसको रट लो बिल्कुल. Silver is the best conductor of electricity, followed by copper, gold, and aluminum. Even aluminum conducts electricity. Is that for real? Aluminum also conducts electricity. And then iron. I'll just ask AI or whatever. Let's say Google. So amongst the following, gold, silver. So let the AI do this work. So the order of increasing electrical conductivity for the metals, aluminum, gold, silver, and iron is aluminum, gold, copper, and silver. Increasing order. So aluminum has the least electrical conductivity amongst these four, and then comes gold, copper, and silver. All right. Electrical conductivity is a material's ability to carry an electrical current. Silver is the best conductor of electricity because it has more free electrons to move than other elements. On a scale of 0 to 100 for electrical conductivity, silver ranks 100, copper at 97, gold at 76, and aluminum at 60. So, okay, you can either learn it like that, or you can learn this. The correct order is AGCS. So aluminum, gold, copper, and silver in the increasing order of electrical conductivity. So I'll just copy that and paste it. AGCS. Okay, so we have saved it. Now resuming our theory, AGCS, that is aluminum, gold, copper, and then silver is the highest electrical conductivity. And then we read that liquid can conduct electricity easily, but for gases to conduct electricity, the gas has to be put at a particular pressure first. Now talking about superconductivity, so when cooled below a certain temperature, materials exhibit zero electrical resistance and zero permeability. This temperature, which is also called as the transition temperature, is where the superconductivity kicks in, and superconductivity is used in MRI, magnetic resonance imaging, nuclear magnetic response. It is also used in fusion reactors or tokamaks, that is the artificial sun, particle accelerators, loss of power through distribution. Why have you written that? Loss of power through distribution. Anyway, so superconductivity occurs when cooled below a certain temperature, materials exhibit zero permeability and zero electrical resistance. So this should be highlighted with different color, because that's actually what is indicative of the fact that superconductivity has kicked in. Okay, so superconductivity ka matlab zero electrical resistance and zero permeability, and that occurs when the material has been cooled down at a below a certain temperature. Then the superconductivity kicks in, and these are the applications. Okay, then the degree of magnetization that a material obtains in response to an applied magnetic field. So the degree of magnetization that a material obtains in response to an applied magnetic field. The permeability and resistance of superconductor is 0. I just talked, ऊपर लिखा तो हुआ है येलो से कि permeability and resistance of the superconductors are 0, and the degree of magnetization that a material obtains in response to an applied magnetic field. What do we call that? Material magnetizes under is called. So the degree to which a material is magnetized in response to an applied magnetic field is called magnetic susceptibility. It's a dimensionless proportionality constant that's caused by the interactions between the material's electrons and nuclei and the applied magnetic field. So the basic term here is that magnetic susceptibility. You better write that down. The degree magnetic susceptibility. So the degree of magnetization that a material obtains in response to an applied magnetic field. Okay, the permeability and resistance of superconductor is 0. Then the only challenge is that superconductivity occurs at very low temperatures. If it could be achieved at normal temperatures, then billions can be saved by preventing energy loss in transmission, because you have to first cool them down using energy. So there's a loss of energy in the transmission. However, there are some fairly high temperature superconductors, and by fairly high I mean minus 135 degrees Celsius, because this is still warmer for conventional superconductors which function at way lower temperatures. So like ceramic oxides, these can behave like superconductors. Then barium, thallium, and so barium and strontium are, they are alkaline earth metals. Anyway, ceramic oxides, barium, thallium, copper oxide, unlike conventional superconductors which require minus 243 degrees Celsius or even lower than that, they still work at minus 135 degrees Celsius, like ceramic oxides, barium, thallium, and copper oxide. Semiconductors, on the other hand, the more cooler they get, the less they conduct. So up till now we were talking about superconductors, and now we come to semiconductors, which actually are opposite of superconductors. Like if you cool them, the more cooler they get, the less they conduct electricity. So at absolute temperature, which is minus 273, I think absolute zero is minus 273 degrees Celsius, Semiconductor behaves like perfect dielectric. With increase in temperature, conductivity in semiconductors increases. In other words, at absolute zero temperature, electric resistance in semiconductor is infinite. All right. So perfect dielectric means, I think it is referring to insulator. Absolute temperature, that is, the more they get cool, they behave like insulators. Or perfect dielectric is the word, which signifies that they are not able to conduct any sort of electricity. However, with increase in temperature, conductivity in semiconductors increases. Okay. Now, germanium and silicon are two commonly used materials for semiconductors. The government of India banned the export of burnt coal, which is also called as jhama, as it contains recoverable amount of metal which is used in transistors. Okay, so I think germanium is the recoverable metal from the burnt coal. Germanium is silvery white, typically obtained from smelting zinc or as a byproduct of burnt coal jhama that I was actually talking about. So export of jhama is now banned because we can recover germanium from it, which can be used as a good semiconductor material. And smelting of zinc also produces germanium. Okay. Now maglev, it is magnetic levitation, which works on the magnetic repulsion theory. Now copper rods are generally preferred to iron rods for making lightning conductors, as copper is better conductor than iron. It does not get oxidized easily. Loss of energy in the form of heat is very low, as copper is a bad conductor of heat, but iron is a very good conductor of heat. So this is another very good point. Like above, we told that AgCs is the increasing order of electrical conductivity of metals, where A stands for aluminum, then G stands for what was that? Hydrogen bomb kahan gaya? Gold. Okay. Ag, then copper, and then silver. So, and I think Ag, silver is the best conductor of electricity, followed by copper, gold, aluminum, iron. So I think iron, I forgot to put iron there. So if I add iron there as well, gold, silver, iron, gold, copper, and silver, it hasn't mentioned about anything about iron. Why? Silver is the best conductor. Okay, I can just ask like which one is better, electrical conductor, copper or iron? Or I can just speak. So which is a better electrical conductor, iron or silver? So silver is a better conductor, or copper. Actually, I meant to ask copper. Silver is the best electrical conductor of the three, followed by copper and then iron. So iron is the least capable conductor of electricity compared to silver and copper. Now you got it. Coming back here, so what I was saying, that lightning conductors are made of copper instead of iron because firstly, copper are better conductor of electricity compared to iron. Copper doesn't get oxidized that easily as compared to iron. Copper is a bad conductor of heat compared to iron. These are the three advantages of using copper over iron while manufacturing lightning conductors. Then current is directly proportional to potential difference. Current is directly proportional to potential difference. Yes, I know that. And this is nothing but Ohm's law, or voltage is equal to resistance into current. So what I said, current is directly proportional to the potential difference. Okay, where R is the resistance of the conductor, R is directly proportional to the length of the wire. Length बढ़ाओगे तो resistance बढ़ेगा, and inversely proportional to the cross sectional area of the conductor. अगर cross section area कम करोगे तो resistance बढ़ जाएगा, और cross section area बढ़ा दोगे तो resistance घट जाएगा, right? So R is, resistance is inversely proportional to the cross section area of the conductor. Then electric power is volt into ampere into hour divided by 1000, that is power, and it is measured in watt. So I think it is measured in watt hour. Okay, yes, watt hour. So volt ampere hour by 1000. So we get watt, but if you want it in terms of kilowatt, then you divide that by 1000. Okay. So 1 unit of electricity is the amount of electrical energy consumed by a load of 1 kilowatt in 1 hour. So 1 watt is 1 joule divided by 1 second. So 1 kilowatt is 1000 joule divided by 1 second into 3600 seconds. For example, अब ये न्यूमेरिकल है, बट अभी के लिए इतना याद रखो कि इलेक्ट्रिकल पावर इज़ मेजर्ड इन दिस फार्मूला इफ़ यू वांट टू प्रेजेंट इट इन द फॉर्म ऑफ वाट. ठीक है, तो फॉर एग्जांपल बल्ब इज़ 100 वाट, तो उसकी पावर दी है 100 वाट एंड इट बर्न्स फॉर 10 आवर्स. वोल्ट एम्पियर आवर डिवाइड बाय 1000. ठीक है, तो फॉर्मूले में रख दो. then consumption equals to 1000 kilowatt hour equals 1 unit. समझ नहीं आया? For example, a bulb is 100 watt, burns for 10 hours, ठीक है? Then consumption is equal to 1000 kilowatt hour. तो watt है, hour से मल्टीप्लाई कर दिए, ठीक है? क्योंकि तुम्हें ऑलरेडी वॉट दे रखा है, हाँ, तो उसको तुम टाइम से मल्टीप्लाई कर दोगे तो तुम्हारा पावर आ जाएगा. तो तुम्हें कितना पावर चाहिए? 1000 किलोवाट आवर, एंड दैट इज़ व्हाट इज़ कन्वेंशनली कॉल्ड एज 1 यूनिट, ठीक है? 1 यूनिट. सो 1 यूनिट ऑफ इलेक्ट्रिसिटी बेसिकली refers to 1000 kilowatt hour. Is that so? Let's ask, is 1 unit equal to, is that, no, 1 unit of electricity is equal to 1 kilowatt hour. 1 unit of electricity is 1000 watt hour, or we can say 1 kilowatt hour is basically 1 unit. So 1 kilowatt hour, so 1000 watt into 60 into 60, that is 3600 seconds. That is what is 1 kilowatt hour. Why are you like, because it is not in minutes. A kilowatt hour is the amount of energy used by a 1000 watt appliance. Amount of energy, 1000 watt appliance running for 1 hour. Okay, for example, a 2 kilowatt heater है running for 3 hours, so uses 6 kilowatt hours of electricity. 6 kilowatt hours of electricity. So what are we doing? We are 6 kilowatt hours. Now if you want to write that down in terms of watt, how will we convert that? I think we'll have to convert hour into seconds. ये क्या किया है? For example, a bulb is 100 watt and it burns for 10 hours. तो 1 किलो तो 100 वाट इंटू 10 कर दो, कितना आ जाएगा? 1000 आ जाएगा. 1000 आ जाएगा, ठीक है? 1000 वाट आवर्स होगा ना वो. कुछ कन्फ्यूजन तो है यार. यहाँ पे क्या है कि अ किलो वाट आवर इस द अमाउंट ऑफ, तो यहाँ बल्ब कितने का था? बल्ब 2 किलोवाट, नहीं, हीटर 2 किलोवाट का था. वहाँ तो मैंने सिर्फ 100 वाट लिखा था. तो यहाँ पे थोड़ा कन्फ्यूजन है, ठीक है? तो ये दोबारा देख लेना, न्यूमेरिकल कैसे सॉल्व होगा ये देख लेना दोबारा, ठीक है? तो अभी फ़िलहाल के लिए इतना याद रखो कि इलेक्ट्रिकल पावर इज़ वोल्ट इंटू एम्पियर इंटू आवर, या फिर सिंपली सीधे पावर दे रखी है वॉट में तो दैट इंटू आवर, दैट विल बी द इलेक्ट्रिकल पावर कंजम्पशन, ठीक है? ये समझ नहीं आ रहा है मुझे. एनीवेज, मूविंग ऑन. सो डिम बल्ब हैज़ मोर रेसिस्टेंस वाइल ब्राइटर बल्ब हैज़ लेसर रेसिस्टेंस. वो कम रेसिस्टेंस है तभी तो वो ज़्यादा चमक के चल रहा है, ठीक है? डायनमो इज़ एन इलेक्ट्रिकल जनरेटर दैट क्रिएट्स डीसी यूजिंग कम्यूटेटर. तो डीसी यूजिंग कम्यूटेटर टेक्नोलॉजी किस में है? डायनमो में. इट कन्वर्ट्स मैकेनिकल एनर्जी इनटू इलेक्ट्रिकल एनर्जी थ्रू इलेक्ट्रोमैग्नेटिक इंडक्शन यूजिंग फैराडेज लॉ. इलेक्ट्रोमैग्नेटिक इंडक्शन का इस्तेमाल होता है फैराडेज लॉ, और डीसी करंट जनरेट होता है यूजिंग अ कम्यूटेटर. डायरेक्ट करंट जनरेट होता है यूजिंग अ कम्यूटेटर. इलेक्ट्रोमैग्नेटिक इंडक्शन यूजिंग फैराडेज लॉ. इलेक्ट्रिक मोटर also uses जो पंखे में होता है Faraday's law of electromagnetic induction. So both dynamo and electric motor use electromagnetic induction principle. इलेक्ट्रॉनिक जो इलेक्ट्रिक मोटर होता है पंखे में वो भी Faraday का electromagnetic induction principle पे काम करता है. Electric motors operating at low voltages tend to burn because they draw more current which is inversely related to voltage. ठीक है, because they draw more current. Voltage low हो जाता है तो they start drawing more current and then they burn. Now car battery usually has 6 2-volt cells connected in series which gives it a steady voltage of 12 volts. The capacity of battery is expressed in ampere hour. Ampere hour में तुम्हारा बैटरी की कैपेसिटी लिखी होती है. Electrolyte used in the cars are 35% H2SO3. H2SO3 है कि 4 होगा, and 65% water. So what is the electrolyte that is used in car batteries? Sulfuric acid is the electrolyte used in the car batteries. 35% solution of sulfuric acid in water. I think I have mistyped that. ये H2SO4 होगा 35% और बाकी 65% वाटर होता है, ठीक है? द इलेक्ट्रोड्स आर लेड डाइऑक्साइड. ठीक है? इलेक्ट्रोड्स आर मेड ऑफ व्हाट? सो दे आर मेड ऑफ द इलेक्ट्रोड्स ऑफ कार बैटरीज आर मेड ऑफ अ वैरायटी ऑफ मटेरियल्स इंक्लूडिंग लिथियम, ग्रेफाइट, निकल, कोबाल्ट एंड मैंगनीज. अब यहाँ पे लेड तो दिया ही नहीं है. अब जो लिखा है वहाँ घटना चक्र में उसको ही मानेंगे. तो लेड लिखा है तो लेड मान लो, लेड डाइऑक्साइड. Nickel cadmium batteries are the rechargeable wala batteries. Potassium hydroxide is alkaline electrolyte used in calculator cordless equipments. ठीक है? तो पोटेशियम हाइड्रोक्साइड किसका इलेक्ट्रोलाइट होता है? कॉर्डलेस या कॉर्डलेस इक्विपमेंट्स का होता है, कैलकुलेटर वगैरह में, ठीक है। एल्कलाइन इलेक्ट्रोलाइट होता है पोटेशियम हाइड्रोक्साइड, कॉर्डलेस एज वेल एज कैलकुलेटर में इस्तेमाल किया जाता है। An ordinary light bulb has a rather short life because the filament wire is not uniform. Bulb cannot be evacuated completely. Wires melt at high temperatures. ठीक है, टेम्परेचर ऑफ इलेक्ट्रिक बल्ब इज़ 1500 to 2500 डिग्री सेल्सियस, जो उसका फिलामेंट होता है उसकी बात कर रहे हैं। 2000 डिग्री सेल्सियस होता है भाई साहब। लाइटनिंग कैन बर्न अ ट्री एज इट कंटेन्स ट्रिमेंडस अमाउंट्स ऑफ इलेक्ट्रिकल एनर्जी। ठीक है, तो अब ये इस पेज से हम लोग अगले वीडियो में देखते हैं। 2 पेज करने हैं बस, 3 हो गया, ठीक। तो इसमें थोड़ा सा कन्फ्यूजन था ये न्यूमेरिकल्स वगैरह में। अभी के लिए ये मैग्नेटिक लेविटेशन देख लो, ये मैग्नेटिक रिपल्शन होता है, ठीक है। कॉपर रॉड्स आर जनरली प्रेफर्ड टू आयरन रॉड्स फॉर मेकिंग लाइटनिंग कंडक्टर्स, ये भी बता दिए वाई। नाउ करंट इज़ डायरेक्टली प्रोपोर्शनल टू पोटेंशियल डिफरेंस, जितना ज़्यादा पोटेंशियल डिफरेंस उतना ज़्यादा करंट होएगा। दिस इज़ बेसिक ओम्स लॉ, ठीक है। बाकी V इक्वल टू आर आई होता है, वोल्टेज R इंटू आई इज़ करंट, ठीक है। Now R is directly proportional to the length and inversely proportional to the area of cross section of the conductor. Now electric power क्या होता है, ये इसी में confusion हो रहा था। इलेक्ट्रिक पावर होता है वोल्ट इंटू एम्पियर इंटू आवर डिवाइडेड बाई 1000। सिंपल टर्म्स में इलेक्ट्रिक पावर ये होता है। और क्या कह सकते हैं, देखो वोल्ट इंटू एम्पियर बेसिकली V इंटू आई इंटू टी, तो ये तो हो गया वॉट, ठीक है। तो वॉट क्या है, वॉट वोल्ट इंटू एम्पियर की जगह वॉट लिख दो और टाइम लिख दो, ठीक है। तो पावर इज़ वॉट इंटू टाइम, ये भी एक तरीका है लिखने का, ठीक है। तो यहाँ एक बार देख लेते हैं व्हाट इज़ द फॉर्मूला फॉर पावर। सो P इज़ इक्वल टू वी आई है ना, वोल्टेज है, पोटेंशियल डिफरेंस एंड I इज़ द इलेक्ट्रिक करंट एंड P इज़ द इलेक्ट्रिक पावर। तो वही चीज़ तो यहाँ लिखी है, यहाँ वोल्टेज लिखा हुआ है, ये देखो वोल्ट लिखा है, एम्पियर बेसिकली I होता है, तो V इंटू आई दैट इज़ वॉट। तो वॉट को कर दिया तुमने आवर से मल्टीप्लाई, ठीक है, दैट इज़ टाइम। तो वॉट इंटू टाइम इज़ पावर। और यहाँ तो 1000 से डिवाइड इसलिए कर रहे हो ताकि तुम्हें आंसर किलोवाट में मिले, वरना तुम्हें यहाँ पावर वॉट में मिलेगा, ठीक है। वॉट इंटू टाइम होता है। पावर की यूनिट क्या होती है, पावर की यूनिट, तो पावर की यूनिट होती है आई थिंक वॉट आवर होनी चाहिए। इन द इंटरनेशनल द यूनिट ऑफ पावर इज़ वॉट विच इज़ इक्वल टू जूल पर सेकेंड। अदर कॉमन एंड ट्रेडिशनल मेजर्स आर हॉर्स पावर। तो ठीक है, पावर की यूनिट तो वॉट हो गई, V इंटू आई, पावर इज इक्वल टू V इंटू आई, वोल्टेज इंटू करंट, तो वो क्या होएगा, तो V इंटू आई। ये टाइम से क्यों मल्टीप्लाई कर रहे हो भाई, पावर इज इक्वल टू V इंटू आई होता है, V इंटू आई। बाकी यहाँ वॉट इंटू आवर्स कर दोगे तो पावर कंज्यूम आएगा, क्या क्या आएगा, अब इसमें देखना पड़ेगा।